One more problem from limits. Here, show that first problem limit extends to 0, 1 minus cos 2mx by sin square nx. Sin square nx is equal to 2m square by n square. Here, you see, we have to prove this one. We have to prove this one. This one. Here we know that 1 minus cos 2 theta is equal to 2 sin square theta. By using this formula here, this can be written as limit x tends to 0. 1 minus cos 2 mx, that is 2 sin square mx by 2 sin square nx. Okay, all of you. So here 2 constant common. This is 2 into limit x tends to 0. Sin square mx by x square by here this one only sin square nx by x square. So this can be written as this is implies 2 into here 2 into limit x tends to 0. X tends to 0 sin square mx by m square x square into m square by limit x tends to 0 sin square nx by n square x square into n square. Okay, all of you. This is implies 2 into m square by n square into limit here x tends to 0. X tends to 0 implies mx tends to 0. X tends to 0 implies nx tends to 0. We can use this one. So limit mx tends to 0 sin mx by mx whole square by this one limit x tends to 0 sin nx by nx tends to 0 whole square. So what is the value of this one? This value is 2m square by n square into 1 by 1. That is 2m square by n square. This is the RHS. This is the RHS of the problem. Okay, all of you. RHS of the problem 2m square by n square. Okay, all of you. That's all. Here we have one more problem. Limit x tends to 0. Sin of a plus bx minus sin of a minus bx by x is equal to 2b cos a. So here you see here this is in the form of sin c minus sin d is equal to 2 into cos c plus d by 2 into cos c minus d by 2 into sin c minus d by 2 cos c minus cos d. So this is sin c minus sin d is equal to 2 cos c plus d by 2 into sin c minus d by 2. This is the transformation formula. So we can use this formula here. Okay, all of you. So what is the remaining? Limit x tends to 0. By applying this formula, 2 into cos of c plus d. A plus bx plus a minus bx. A plus bx plus a minus bx by 2 into sin a plus bx. A plus bx minus a plus bx by 2 by denominator x. Okay, all of you. Here minus a plus a cancel, minus bx plus bx cancel. What is the remaining? 2 as common, 2 common, limit x tends to 0. Here cos 2a by 2, that is cos a, into sine of 2bx by 2, that is bx, by denominator x. So here cos A is constant, you can take into this side. This is implies 2 into cos A, limit x tends to 0, sine bx by x. You can multiply with b and divide with b. So what we can written here, this is implies 2 cos A into limit as x tends to 0 implies bx tends to 0. Bx tends to 0, sin bx. Here 2b, b also common, 2b cos a into sin bx by bx. But sin theta by theta, limit theta tends to 0 is equal to 1. This is the formula. By using this formula, 2b cos a into 1. Therefore, 2b cos a is the RHS, hence the proved. Okay, all of you, hence the proved. That's all. Here we have one more problem. Find limit x tends to 0, 3 power x minus 1 by root over 1 plus x minus 1. So here you see all of you, we have given limit x tends to 0, 3 power x minus 1 by root over 1 plus x minus 1. This can be written as limit x tends to 0, 3 power x minus 1 into 1 by root over 1 plus x minus 1. You can divide with x and multiply with x. Then this is implies limit x tends to 0, 3 power x minus 1 by x into limit x tends to 0, x by root over 1 plus x minus 1. Okay, all of you. So here this is implies, we know that formula, limit x tends to 0, a power x minus 1 by x is equal to, this is log a. This value is log a. So one more, limit x tends to 0, x power n minus a power n by x minus a is equal to n into a power n minus 1. By using these two formulas here, this value is what? Log 3. Log 3 into this value is what? Here this can be written as 1 by limit x tends to 0, root 1 plus x minus 1 by, here 1 plus x minus 1. Add 1, subtract 1. So this is x minus a, x minus a. So log 3 into 1 by, this is limit x tends to 0, 1 plus x whole power 1 by 2 minus 1 power 1 by 2 by 1 plus x minus 1, x power n minus a power n by x minus a. So this is log 3 into 1 by 1 by 2 into 1 power 1 by 2 minus 1 equal to what? 2 into log 3. 2 into log 3 base c. This is the answer. Okay, all of you. That's all. Here we have the problem. Compute limit extends to 0 e power x minus 1 by root over 1 plus x minus 1. So you can solve this problem similar to previous problem. So this is, you see, first problem, limit extends to 0 e power x minus 1 by root over 1 plus x minus 1. So you can write as limit extends to 0 e power x minus 1 by x into limit extends to 0 x by root over 1 plus x minus 1. But what is the value of this one? Log e base e into this value is 1 by 1 by 2. This is equal to 2 log e base e is equal to 2. You can solve this problem by this method. So detailedly you can solve. Okay, all of you. Next you go for this problem. Second one. This is hint. Okay. So here second one you see limit extends to 0 a power x minus 1 by b power x minus 1. So limit extends to 0 a power x minus 1 by x by b power x minus 1 by x. So limit extends to 0 a power x minus 1 by x by limit extends to 0 b power x minus 1 by x. What is the value of a? This one, log a by log b. So this is log a base b. This is the answer. Okay, all of you. Log a base b is the answer. That's all. Thank you. Here we have the problem. Find the limit extends to 0 cos ax minus cos bx by x square. So here this is in the form of cos c minus cos d is equal to 2 sin c plus d by 2 into sin d minus c by 2. By using this formula here, so this is implies. This can be written as limit extends to 0. 2 into sine of a plus b by 2 into x. This one sine of b minus a by 2 into x by x square. Okay, all of you. So here this is the, here 2 is the constant, 2 common, limit extends to 0. This can be written as sine of a plus b by 2 into x by x into limit extends to 0 sine of b minus a by 2 into x by x. Okay, all of you. Here, this is extends to 0 as a plus b by 2 extends to 0. Similarly, here extends to 0 implies b minus a by 2 extends to 0. So, you see here, this can be written as, this can be written as 2 into limit a plus b by 2x, a plus b by 2x tends to 0. This is sine a plus b by 2x by a plus b by 2x. You multiply, divide with a plus b by 2 and multiply with a plus b by 2. Okay, all of you, into limit a b minus a by 2x tends to 0. This is sine of b minus a by 2x by b minus a by 2x into b minus a by 2. Okay, all of you. So here we know that limit theta tends to 0, sin theta by theta is equal to 1. By using formula here, this is 2 into this total value become 1 into a plus b by 2 into this total value become 1 into b minus a by 2. Okay, all of you, 1, 2, 2 cancel. This is b plus a, b minus a. So b square minus a square by 2 is the result. Hence the result. Hence proved, or hence the result. Okay, all of you, that's all. Thank you. Here we have one more problem. Find the limit extends to infinity root over x square plus x minus x. So here you see this is the limit extends to 0 root over x square plus x minus x. Limit extends to 0 root over x square plus x minus x. By substituting infinitive, we get infinitive minus infinitive indeterminate form. So here limit extends to infinitive, we can written as this is root over x square plus x minus x into this is root over x square plus x by root over x square plus x. By using this formula, you observe this numerator a minus b into a plus b. A minus b into a plus b is equal to a square minus b square. By using this formula here, this is implies limit x tends to infinity. This is root over x square plus x whole square minus x square by denominator root over x square plus x plus x. Here square root cancel. This is implies limit x tends to infinity. Here x square plus x minus x square by root over x square plus x minus x square plus x square cancel. So this can be written as limit x tends to infinity x by from denominator you take from this x square as common, this is 1 plus 1 by x. So root over x square as common, 1 plus 1 by x plus x. Okay, so limit x tends to infinity x by from denominator x as common. This is root over 1 plus 1 by x plus 1. Okay, all of you. Here x cancel. Then what is the remaining? Limit x tends to infinity 1 by root over 1 plus 1 by x plus 1. As x tends to infinity implies 1 by x tends to 0. So what is the 1 by x value? 0. By applying limit value here, 1 by here root over 1 plus 0 plus 1 is equal to 1 by 2 is the answer. Okay, all of you. That's all. Thank you. We have one more problem. Limit extends to pi by 2 cos x by x minus pi by 2. Let us here limit extends to pi by 2 cos x by x minus pi by 2. Let you take x minus pi by 2 is equal to y. So x tends to pi by 2 implies x minus pi by 2 tends to 0 implies y tends to 0. Okay, but here x minus pi by 2 tends is equal to y. So x is equal to y, x is equal to what? Y plus pi by 2. by taking to this side, that is y plus pi by 2. So here this is limit x tends to 0, x tends to 0, y tends to 0, y tends to 0, cos x, that is cos of y plus pi by 2 by this value is y. Okay, all of you. So this can be written as limit y tends to 0 cos of pi by 2 plus y by y. Then what we can written as limit y tends to 0 cos pi by 2 plus theta is minus sin theta, minus sin y by y. So minus limit y tends to 0 sin y by y. So limit theta tends to 0 sin theta by theta is equal to 1. By using this formula here, minus of 1 is equal to minus 1 is the answer. Okay, all of you. Thank you. Here we have one more problem. Find the limit x tends to infinity to 11x cube minus 3x plus 4 by 13x cube minus 5x square minus 7. So let x is equal to 1 by y implies x tends to infinity as y tends to 0. Okay, all of you. So limit y tends to 0, 11 into 1 by y whole cube minus 3 into 1 by y plus 4 by denominator 13 into 1 by y whole cube minus 5 into 1 by y whole square minus 7. This is implies limit y tends to 0. Here numerator y cube as LCM, 11 minus 3y square plus 4y cube by denominator LCM y cube, 13 minus 5y minus 7y square y cube. Here y cube as common. Then you say limit y tends to 0. Here 11 minus 3y square plus 4y cube by denominator 13 minus 5y minus 7y cube. Okay, all of you. Then after you have to substitute the limit value. 11 minus 3 into 0 square plus 4 into 0 cube by 13 minus 5 into 0 minus 7 into this one. This value 0, this value 0. This is 11 by 13. So this is the answer. Okay, all of you. That's all.